Well, hello one more time, everybody. Good to see you guys again. Of course, last Friday we learned that the governor had announced that we are not going to be going back into the building the rest of the year, which honestly did make me kind of sad. I really do miss seeing all you guys, and I wish that we could actually be closer together, but unfortunately, that's not an option that we have right now. We do still have about a month left of school, and we need to make the best of it that we possibly can. Where we're at right now is section 04 in your book, and that section deals primarily with quadratics. You guys should remember from before that a quadratic basically is an equation or a function that has x squared in it. That's the thing that makes quadratic quadratic. And you've done those at least since Algebra 1. I can remember working on quadratics with some of you that summer that we were together in my room. And they come up again in advanced algebra. They do come up in analysis. And honestly, going forward, understanding how to work with quadratics is probably the most valuable skill you can have. That's one of those things that makes the ACT a lot easier. It's also something that's going to keep coming back to haunt you next year in Math 5 and in any college math class that you encounter as well. Sometimes people sort of freak out when they get to quadratics, but there really is nothing new that we're going to be talking about today. We're going to look at two key things, factoring and the quadratic formula. That's really what's up. And you have done everything that we're going to do multiple times before. Really, all you got to do is sort out what you do when and keep it straight. So I'm going to start by showing you three polynomials, and the directions say factor these. I want you to look at those for a minute and think, what would you do to factor each of these problems? Factor, of course, means break it down into parentheses, so how would you do that? If we were in our actual class, of course, I'd want people to raise hands and tell me what they were going to do, but that doesn't work, so we'll just give you a minute to think about it and then show you what the answers look like. Big thing to keep in mind when you're working with factoring problems is that you have to come up with numbers that you multiply to get that constant at the end, and they've got to add up to the number by x. So here I want to multiply to get 40, it's got to add up to 13. What does that is 8 and 5, and that's why I write x plus 8 times x plus 5, and I'm done. That's it. That also works when you have negative numbers involved. Here we've got to multiply to get negative 18, and the numbers I need to have would add up to negative 7. Well, 9 and 2 is one way you could get 18, and one of those has to be negative to make it a negative 18. And if I put things together, negative 9 plus 2, yeah, that is negative 7, so that's why my answer's got to be x minus 9 times x plus 2. Now I'm betting many of you zipped through those other couple of problems with no issues at all. This one, though, does sometimes tend to cause problems. We've got 5x squared minus 25x plus 20. And a lot of times people will look at that and the first thing they try and do is get stuff that'll multiply to be 20, and that doesn't work. What you might notice, though, if you look at this, is that every number in this problem is divisible by 5. 5 goes into 5, 25, and 20. You could take a 5 out of everything. And that is exactly what I'm doing here. I just took out a common factor of 5 and then divided all the stuff in the problem by 5. So we got 5 times the quantity x squared minus 5x plus 4. And now what I'm going to do is take what's in those parentheses and factor that just like I did before. We find stuff we can multiply to get 4 that's going to add up to negative 5. Because of the negative 5, that's why I've got the minuses in the problem, and we do end up with 5 times x minus 4 times x minus 1. That's going to end up being our final answer. So here's another problem that has a coefficient on x squared. This time we've got 3x squared plus 17x plus 20. And the problem this time is that you can't just like divide everything by 5 like I did on the previous one. So I want to see if you can think about that for a second and think back to what do you do on problems like this one. And basically the difference is that when I have 3x squared, I've got to have stuff at the beginning of those parentheses that will multiply to give me 3x squared. And that's why this time, instead of just x, I've got 3x and x at the beginnings of the parentheses. So this is going to be 3x plus something and x plus something. What we're going to do now is we will think about what do I multiply to get 20. That's the same as what we've done in most of these problems. But there's nothing you can multiply to get 20 that's going to add up to 17. However, we can still do this problem. By far the most common way to get 20 is 5 times 4, and it does turn out the right answer to this problem is 3x plus 5 times x plus 4. The way that you can check to see that that's right is to think about what's on the outside and what's on the inside. If you remember FOIL back in Algebra 1, that's the middle part of that. And if I take 3x times 4, I'd have 12x. In the middle, I have 5x, and if you put those together, you get 17x. So when there's a coefficient like that, I've got to check outside plus inside, and that's what's got to add up to the middle. Sometimes you'll have problems like this one, where it says 6x squared plus 5x minus 56. This time, instead of just 6x and x at the beginning, what I'm going to do is put 3 and 2. I think what's the most common way that you can multiply and get 6, and that's what I put at the beginning of the parentheses. Now, just like before, I've got to think, what can I multiply to get negative 56? And if I do outside and inside, how is that going to work out to be 5? So stare at that for just a second and see if you can figure this one out. Since we are multiplying to get negative 56, that's how I know that one of these numbers has to be a minus. And it does turn out that negative 8 times 7, that gives me the negative 56. Now if I check the outside, I'd have 21x. On the inside, I have minus 16x. You put those together, and yeah, that really does add up to 5x. So 3x minus 8 times 2x plus 7. The book assignment, where all of this is based from, has a bunch of problems that look like this, where it's basically written backwards. Here it says 18 plus 3x minus x squared, and you're supposed to figure out what to do with that. There's actually a couple of ways that you can do problems like this. I'm going to first of all let you look at it for just a second, and then we'll talk about both of the possible ways. Having a negative x squared kind of screws everything up. And one of the best things to do when you've got something that's written that way is to factor out a negative. That means put a negative out front and then change the sign on everything. What you're essentially doing is dividing everything by -1. And you end up with a problem that's equivalent to what you had, but it's easier to work with. Then you can make it easier to factor if you just turn things around and write it in the standard order. So here we've got negative x squared minus 3x minus 18. Once I've got it that way, it's just like every other problem. What do you multiply to get negative 18? That's going to add up to negative 3. And it does turn out that the final answer is going to be negative, or the opposite of, x minus 6 times x plus 3. When I see problems like that, I tend to always do what I just did and take out a negative so that the x squared part's positive. I just find it easier to do if the x squared's always positive. You can, however, take something like this and factor it backwards. Basically, you got to find stuff you can multiply to get 18. You need to find stuff you can multiply to get negative x squared. And when you get done, it's got to add up to 3 in the middle when you check outside and inside. And here we would indeed have 18 at the beginning. Negative x and positive x makes negative x squared. And if I do outside and inside, I'd have 6x minus 3x, and that does give you the 3x for the middle. That looks different than the original answer I had, but it's just another way of writing the same thing. So this is a real similar problem. I want you guys to take just a minute and see if you can figure out what's going to happen with 28 minus 3x minus x squared. And here I've got both of the ways that you could write the answers. You can either say that it's 7 plus x, 4 minus x, or you can put a negative out front and it ends up as x minus 4 times x plus 7. Again, those look different, but they're just different ways of writing the exact same thing. So sometimes instead of saying factor, what a problem might say instead is find the solutions to something. And here I've got a couple of problems where it does say figure out the solutions. These might also be called the zeros or the roots. And basically it means what would make this equal to 0. To do that, what you want to do is factor, and then you do the opposites of those factors. That's because if I did 3 minus 3, I'd have 0. If I did 4 minus 4, I'd have 0. So when you're supposed to find the solutions, it's always the opposites of the numbers you have for factors. Here, when we factor it, we'd get 2x plus 3 times x minus 5. Again, if you check outside and inside, you'll have negative 10 plus 3. So yeah, that is negative 7 in the middle. When you have a coefficient like this, your answer is always going to be a fraction. And this time what it is negative 3 halves. And then, of course, the other answer is 5. You can always get that by just looking at your numbers and reading it backwards. What you're technically doing is solving the equation 2x plus 3 equals 0. Move the 3 over, divide by 2, that's why it's negative 3 halves. So here's one more problem. Again, we're going to find the solutions, and it says find the solutions to 5x squared plus 3x minus 1. And I'll let you look at that for just a second, although honestly, not all that long. So a lot of times people will mentally check a problem like that and they'll say, well, if I try to get negative 1, it's just got to be 1 and negative 1 at the end. And if you start doing outside and inside, none of that is ever going to add up to 3. And back in Algebra 1, if I gave you a problem like that, we would have said it's impossible. But the further you go in math, the more you realize that basically we say in advanced math, nothing's impossible. If you can't do it the way you're expecting, find a way to do it. And you already do know how to do problems like this. What we're going to do is use the quadratic formula. You might even remember that 2 or 3 weeks ago you had some problems where that was exactly what you were supposed to do, was figure out what's A, what's B, and what's C in the quadratic formula. Remember, A is always the number by x squared, B is just the number by x, and C is the constant, usually at the end. And you plug them into the formula, see what you get. So here in this problem, what I'd end up doing is taking negative b, the opposite of b, so negative 3 plus or minus square root of 3 squared, which is 9, minus 4 times 5 times negative 1 all over 10. Now exactly how you write the answer, or technically answers, depends on what you're doing. Most of the time in advanced math, we just write the answer like what you see on the left side. All I did there is I just simplified what's under the square root. I figured out that's really 9 plus 20. And that's why our answer would be negative 3 plus or minus the square root of 29 all over 10. Now, that's technically two answers because you've got negative 3 plus the square root of 29 over 10, and then negative 3 minus the square root of 29 over 10. And if you look over at the right where I've got the calculator shot, that's what I did, is I just literally worked that out, divided stuff by 10, and I got two different answers there, which are just the decimal equivalents of what you have over on the left side. Unless it tells you you're supposed to write a decimal, honestly, I would just leave it with the square root, and that's perfectly okay. So one last problem I'll give you a minute to look at here. Let's see if you can come up with the answers for this one. The thing that's most important here is exactly what you did a couple of weeks ago in class. You got to make sure that you have right what's A, what's B, and what's C, because this one's not written in order. And again, A is going to be the number by x squared, so negative 2. B is your coefficient on x, so 7. And C is the number by itself, which is 3. Once you know A, B, and C, you just plug everything where it belongs in your formula. Our final answer here is negative 7 plus or minus the square root of 73 all over negative 4. So this week is just a review of factoring and the quadratic formula, but you do have everything that can go wrong with those all in one place. You will want to probably practice with some of the problems that are online, and of course you do have a quiz over that this week. And then next week we're going to go on and use those to solve equations that you wouldn't even have looked at before, but things that are fairly easy to solve once you do understand factoring and quadratic formula. So we'll leave it at that for this week. Take care and have a good week.